Our next step is to solve some exponential equations. There are some that are going to be really easy that you don't even have to use an inverse operation to be able to solve them. For example, this first one should be very clear to you that x is going to equal 3. 2 to the what power equals 8. We did that in the last video. The way that we're going to officially solve these, for some of the ones that get a little bit more difficult as you look down the screen, is really you need to try to get the same base on both sides. Meaning, I can call 8 2 to the third power. Once I have my bases the same, it's like I can just go and basically get rid of the bases and be left with just x equals 3. That's the steps we're going to use on all these problems. So on this next one, for example, same idea. We have 2 to the x minus 4 on the left. On the right, I'm going to call it 2 to the third. So that means I can now take my insides as being the same and say, well, x minus 4 has to equal 3. So that means my answer is x equals 7 when I solve that equation. For this last one, still 2 to the x plus 3 on the left equals, well, 8 is 2 cubed. That's what's being raised to the 2x minus 6 power. So when I simplify that, because now I have the same base, this is x plus 3 on the left. The right-hand side, I have a power to a power. That means you have to multiply. So it's really you're multiplying this entire thing. It's almost like you're foiling through. So 6x minus 18 becomes the value on the right. Now you have your equation to solve. You get 5x is equal to 21. So x equals 21 over 5. And you're going to get a bunch of fraction answers. This is very common in these problems. So let's look at a couple that are a little more difficult. The biggest problem is figuring out what the value is that your common base has to be. In this case, your common base is 4, because 16 is 4 squared. So you have me poorly writing a 2, 4 squared to the x plus 1 power, 4 to the x minus 7 still over here. Once the bases are the same, you get rid of them and work just with the exponent. X minus 7 equals, make sure you do power to a power to make 2x plus 2. And when you solve that equation, you should get x is equal to, I believe it ends up being negative 9. Let's look at me going off my screen. There we go. Your like base between 3, 1/9, and 27. Well, 3, 9, and 27 are all raised from a power of 3. So that means this has to stay as 3 to the x. 1/9 would be 3 to the negative 2nd power. So that's what's going to be 1/9 is the same as 3 to the negative 2nd. The rest stays the same there. Equals, and 27 is 3 cubed. So that stays as 3 cubed. The exponent goes to 2x plus 3. Now, as you simplify this problem, you have power to a power, so those guys are going to multiply right here. But you have two bases being multiplied together. That means that you have to add those exponents. So x plus negative 2 times x plus 2. And then on this side, power to a power. So again, you multiply 6x plus 9. There's your equation. Now you solve it. X minus 2x minus 4 equals 6x plus 9. Solve for x, and you should get x is equal to, what do you get? Negative x. So you get 7x equals negative 13. So x equals negative 13 over 7. And this last one here, this is a tough one usually to look at. 7 to the something equals 1. In finding your like base, anything to the 0th power is equal to 1. So that's the way you have to analyze that one. So that means you have the exponents 2x minus 3 equals 0. So x is equal to positive 3 over 2. And that's just going to be common whenever you get equals 1. That's how you're going to have to work on that each time. Let's look at a couple more. I'm going to actually advise you to pause the video and give these ones a try. Hit pause and come back when you're ready. Alright, this first one, we have 3 is going to be your common base. So the first one stayed the same. 3 squared times x minus 2. So that means you have x minus 4 is equal to 2x minus 4. So it looks like you're going to get x equaling 0 for that problem. Pretty easy. This one on the right is kind of like the one that we just did, where you have to write this right-hand side as x to the 0th. So x plus 8 is going to equal 0 as a result. And that means x is just going to equal negative 8 for your answer. This last one is probably the toughest one of any of them here. Reason being, you need to look, okay, 4 is your smaller number, but 4 squared or 4 to the any power doesn't equal 8. Your like base in all the ones we've done so far has been one of the numbers we've had. This one's a little bit different. Your like base is actually 2, because 4 is 2 squared, 8 is 2 cubed. Everything else stays the same, and this is x plus 1. Now you can eliminate the bases because you have the same thing. 6x on the left, 2x plus 2 on the right, so 4x equals 2. X should equal 2 over 4, which reduces to 1 over 2. And that there is how you solve exponential equations without having to use logarithms.